If you've watched the last couple of videos talking about generics and the examples of using generics, I said at the end of the video that this video we're going to implement the entity store. Well, we are, but the first thing we're going to be talking about is the associated type, because it's probably the most confusing thing that there is. So we're going to implement the initial part of this entity store in this video, and then go through implementing the rest in the up and coming video after this, because this is the thing that's going to confuse you the most. All right, so I'm going to take time out in this video to talk about why we use the associated type and how it helps us. So with that said, let's first of all create a container struct. Okay, and this container struct initially wants to hold a value of, we're just going to say type of any, and we're going to give it an initializer, and we're going to set the value of that there, and then we're going to say get a value, and this is then going to return the value that we've got in there. All right, super simple, super nice. And now we're just going to say container is equal to new container, and then the value is of 1. Nice. Now what we want to be able to do with generics, as you've seen in the other videos, we want to be able to turn this 1, because any can just take any type whatsoever, but we don't really want to have this container be implemented for integers, for strings, for collections, etc. We just want this value to take on any type whatsoever. All right, so what we can do here is say that we can extract this type out to T. All right, and we do it with the angle brackets, and this is not using protocols. So when you want to use a generics in protocols, this is where the associated type comes into it. However, let's just stay with the actual types first of all right? And we can do this now, and we can see here now that the container is of type integer. And if we then change it once again, we'll just call this then container int, and then we can call this container string. And when we change this to David, you'll see here that we get a container of type string. So this is generics, right, without talking about protocols. Now the power comes in the protocols, right? Generics, we're just with concrete types. It is super easy compared to using protocols. But like I said, it's like taking a hammer is generics, right? But if you want Thor's hammer, that's protocols, right, with associated types. So there's the two differences. They're both two tools, but Thor's hammer is a way better tool, and only Thor can use Thor's hammer. And this is why it's important, because only integers can use this container. All right, if that T has provided some form of conformance requirements, some prerequisites that it's got to be like an integer, for example, or it's got to, anyway. So this is now the container without a protocol. So let's now say that we've got a protocol here, and it's going to be a value container, right? And we're going to say here the associated type is of type T, and the of type T, and then the function should have a function of get value, and that should be then T as well. All right, super simple. So we can say here now value container, and it needs to implement this. Well, you can see right now that it's already implemented get value, and it returns the type T. But if we remove this from the top, you can see now that the compiler is saying, hey, I have no idea how to infer this value T, because you haven't told me what it is. So now we could put integer here, right, and then put integer here, and then integer here, and you can see now the compiler's like, well, I'm happy, because get value is returning an integer, and value is of type integer. So and we are setting an integer here as well. So I'm all right to allow you to do this. Let's just remove this. But now we have hard coded this container to be of a integer once again. So we used generics here, but then we stopped it from being generics once again. So this is a little bit silly, right? It's a little bit silly, because it means that we have to define integer, integer, integer all down here all the time. So what about if we just use type alias, and we just say type alias is equal to integer, And now we can take the T, the T, the T here, and we have exactly the same thing. So it now means that if we want to change this container's type, we could change it to string right here and the compiler would complain. However, when we put David here, the compiler would not complain anymore because the usage of this container, see, is of T, but we are giving it of string. Now, what about if we want to extract the type definition to type annotation from outside of it rather than inside of it? Well, we can do this really quite easily. And if we just say this is then going to be the value, right, here, 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 and here, and now rather than it being a string, what we want to do is we want to move this outside, and we're going to move it to here now as well. So now we are saying, hey, the implementation itself is going to be the thing that defines what the associated type is going to be, you see? So the compiler is happy because type alias and associated type, they are like the reflection of one another. This is the inside of the protocol and this is outside of the protocol. So in order for you to implement the associated type, use type alias, and the compiler is happy. And as long as you use that value throughout your code where the generics, the associated type inside of the protocol was used, then it will be happy with that. And now we can literally make, say, an item here, say 1, right? And put this item here. Whoops. Put this item here, and it's fine. And we can see now we get container of type T. And so, but we know that the item is of type integer, and we could explicitly set this to be a container of integer. Now, if we set this to be container of string, then it would moan because it's saying, hey, cannot convert value of int to expected argument of type string. So you can see that we can create more than one of these, and we can just compile this. And this one will work because we've told the implementation of container what type the type alias should be, and that has then gone and told the protocol and say, hey, yeah, I conform here perfectly. My parameter, or the arguments coming in, it conforms to what I'm requiring from T, and that sets value as the same thing here. So it's happy to do this. Now, you could obviously do this as well, is you could say that value, rather than being a single value, right? You could then make it an array instead, and then you just change this, and the only thing you've got to change now is this, right? So now you have a collection type, right? So you're initializing it with a collection, and you're returning the value. Okay, this might want to say get values, for example, and this then might be like T and so on. And now it's a lot more happier. The only thing it's moaned about is down here. So let's now say this here, and we'll say new container of type integer, and then value is then, let's say 1, 2, 3, 4, and so on. And everything is perfectly fine here. And we do another one with strings. And we say David's and Thorn. All right, so everyone is happy. So this is the associated type and the type alias, and passing that responsibility to the usage as well. And this would then be the usage. Now, you've always got to make sure that you can pass on you always got to be able to make sure you can pass on the types, okay? And I don't really want to say much more than that, because we can say type here, all right? And on all types, you can always get the actual type as well. But that's a little bit more complex, and that's maybe for another video. With that said, we are definitely, and I think if you aren't able to implement this entity store right now, if you aren't able to implement that entity store with this information, then don't worry about it, because we're going to do it in the next video. But you should have enough information right now to be able to implement that. The only thing that's missing here really is this bit, but that's saying nothing more than that T has to conform to identifiable, all right? And if we quickly just jump inside of here, you can see that identifiable also has a generic type of ID, and its associated type is ID. So it's passing it from outside in, but it's saying, hey, this ID has to be hashable. You see? So you can keep chaining this all the way down. All right. With that said, thank you very much for watching. Don't forget to like, subscribe, share, and do all of the other social media things that are out there. And if you do have any questions, feedback, or concerns, then let's start a conversation in the comment section down below. If you've got this far and you understand all this stuff right now, the people who I'm asking, they know who I'm talking about because I'm on daily contact with you, asking how it's going, and you're giving me feedback. I really, really need you to tell me, have you been practicing it? Can you implement this without the videos? If you can do, really, really well done. Really, really well done. But it's going to get harder, all right? And the learning curve is going to get tougher. But if you've got this far, you can cope with this, all right? And we've still got concurrency and a lot of other things to talk about too. But this is a lot more harder than the other things. However, the complexity gets more. With that said, thank you very much for watching. My name's David Dawn, and yeah, that's it. See you in the next video. Ciao, ciao, and goodbye.